Hello everyone, this is part 3 from section 2.7, and in this section we are going to introduce new definition, which is the derivatives. So what is the derivative of any function? The derivative of any function is basically the slope of the tangent line for any curve at any point. So the formulas that you used in part 1 and part 2 are called the derivatives. They are basically the derivatives, okay? And the notation for the derivative, if I have the function f of x is equal to x squared plus 1. So the derivative, or the notation for the derivative of that function, or the slope of the tangent line, can be represented as f prime. We say f prime of x, which is the slope of the tangent line, or we can denote it also by d of f of x by dx. So if we say f prime, this means that it's the derivative, or if you say d by dx, this is also another notation for the derivative. So the derivative is equal to the slope of the tangent line and can be found by these two formulas. They are exactly the same formulas that you use for the velocity and that you use for the slope of the tangent line. So the velocity is basically the derivative of the position curve. Okay, let's go to an example where it asks from us to find the derivative of that function. So to find the derivative of that function at a number a. To find the derivative of the function, you can use either two formulas. It's totally okay. But for that example, I'm gonna use the first formula. So here's my f of x. I have my f of x, but here I need to find the derivative in general. The question didn't specify any a. He didn't ask me to find the derivative at a is equal to 5 or a equal to any number. So we are going to find the derivative in general for that curve. Okay, so I'm gonna apply the formula. F prime of a is equal to the limit when h goes to 0 for f a plus h minus f of a over h. What is your f of a? F of a is just, you are going to substitute every x by a, and thus you are going to substitute every x by a plus h. So f prime of a will be equal to the limit when h goes to 0 for what? For a plus h squared minus 8 times a plus h plus 9. This is the first part. About the second part, minus, this is the first part, minus the second part, which is equal to a squared. Instead of every x, I'm gonna replace every x by a, and it will be a squared minus 8a plus 9 over what? Over h. Okay, I'm gonna go ahead and simplify this expression, limit when h goes to 0. For this, I'm gonna use an a plus h squared is equal to what? To the first one squared plus 2 times the first one times the second one plus the second one squared. And for this, it will be negative 8 times a plus h will be what? I'll distribute in negative 8, and it will be negative 8a, negative 8h. And for that one, I'm gonna distribute in negative sign. So finally, I'll get what? I'll get a squared plus 2ah plus h squared minus 8a minus 8h plus 9 minus a squared plus 8a minus 9 over what? Over h. So if you can see that this part will be cancelled with this part, since we have different signs for them, and this will be cancelled with this, and this will be cancelled with this. So this is equal to limit when h goes to 0. For what? For 2ah plus h squared minus 8h over lh. So if you substitute directly, you'll get 0 over 0. What can I do to remove this 0? I can take a common factor from the numerator, h as a common factor. It will be 2a plus h minus 8 over h. This will be cancelled with this, and I will get an f prime at a is equal to what? I will substitute, after cancelling, I'll substitute every h by 0. So after cancelling, I'll substitute this by 0, and I will get 2a minus 8. This is the derivative of the function x at any point a. Now going to the second example, he needs from us to find what? To find the equation of the tangent line. It's the same question as we solved in part 1 for that curve. And this curve is just the same as that curve that we have found the derivative of it. Okay? And he needs the tangent line at this point. So x1 will be equal to 3 and y1 will be equal to negative 6. Okay? So to write the equation of the tangent line, we need to apply the formula, which is y minus y1 is equal to the slope of the tangent line, x minus x1. So y1 is equal to negative 6 and x1 is equal to 3. Okay? What about the m? The m, we said that the definition of the derivative is equal to what? To the slope of the tangent line. And this m, it is just the same thing, which is the slope of the tangent line. So this m is the derivative. To find m, I can just take what I got from example 4, which is f prime at any point is equal to 2 times a minus 8. Okay? So this is what? This is the slope of the tangent line at any point. But here we are looking at the tangent line at this point. So at this point, as I said, a is exactly the same as x. Okay? So we are looking at the slope of the tangent line at a is equal to 3 or x is equal to 3. So to find m, I'm gonna just substitute a by 3. Then it will be 2 times the 3 minus 8 will be 6 minus 8, and then it will be equal to negative 2. Okay, this is the slope. Finally, y minus 6 is equal to negative 2 x minus 3. Okay, and then minus will be y is equal to what? Y plus 6 is equal to negative, I'm gonna distribute this, negative 2x plus 6. Finally, y, this will be moved to the right hand side. Y is equal to negative 2x plus 6 minus 6. Then y is equal to negative 2x. So this is the slope of the tangent line. This is the equation of the tangent line at the point 3, negative 6. Now coming to the last part, which is the rates of change. The derivative of a function or the slope of the tangent line can be seen also as the instantaneous rate of change. So if you have a question that requires to find the instantaneous rate of change, you will just find the derivative.